Welcome all of you here on behalf of SBGrid and Harvard Medical School. And I'll give a short 15-minute, maybe less talk about just kind of making sure that people know how to use SBGrid and how to get all the tools which are being discussed in this workshop on your computers, maybe for the afternoon session and for Saturday as well. This will be the main focus, and I'll mention the data processing application that we have within the SBGrid collection. So it will be the brief outline. So as you know about SBGrid is the largest collection or library of scientific applications, which is available to any of the scientific communities. We host several main collections, and those are used for structure determination by crystallography, NMR, electron microscopy, SAPS tomography, etc. We also have a number of supporting collections, and we've accumulated those applications in response to the community, people working on the structures, wanting to include visualization, analysis, computational chemistry, molecular biology, whatever other application you need to have on your computer to work in the lab. We also have a number of commercial packages, and this includes right now Schrödinger. We have actually fairly expensive license, which is available to all the academic members. We've recently included Genius for molecular biology, and this has been used by many labs. So all in total, we have about 285 packages, and most of those packages are installed in multiple versions. By default, you're using the latest version, and there is a lot of information how you can switch it. I'm not going to cover it today in the talk. And in terms of the operating system support, this entire library is supported on OS X as well as on Linux operating systems. So I think the major key thing for everybody to understand that the software support, this library, is supported on your local computer. So actually you can get all those applications installed on your local Linux, local laptop, local OS X workstation in your lab. And the way we support it, it's traditionally we have two ways of doing it. The main one, which I guess most of the people at Harvard will be using, is the server installation. When you have a local server at your institution and it is connecting to our local server at SBGrid, and applications are synchronized on a regular basis and over a network file system, this is extended to your workstations. So this provides you with a full version of all the applications, multiple releases, etc. We also have this laptop installation script, which has been in place for a while right now. And this would allow you to have your laptop or local workstation to connect to your local server at your institution and pull the recent versions of all the applications. So this is a smaller portable distribution, but it allows you to have every single application. And this has been working with various successes at different institutions. In many cases, the limitation is getting access to your local server to pull those applications. So just this week, and Ben Eisenborn actually just finished this script, this little utility yesterday. I've tested it on my computer. It works really well. It's a new laptop installation script that will allow you to get the same portable version of applications downloaded to your computer, but instead of connecting to your local server, you will be connecting to the SBGrid central server. So this way you can do it outside of the firewall configuration, outside of any other constraints of your local institution that you might have. And in order to set it up, you have to follow up this 4-step initial configuration. And once you have this in place, then the subsequent updates are really simple. It's just as simple as running a simple one-line command. So just to kind of give you an overview again of what I discussed, we have this central SBGrid file server, only one for the entire consortium, and everybody's connecting to it. If you have the local installation, your departmental server will connect to this server and pull the changes. The new installation which we're putting in place, installation method that we're putting in place right now, will involve you connecting on demand to this SBGrid file server to pull all the software to your computer. So the installation, I mentioned 4 steps for this installation. Step 1, you have to get your prerequisites in place. In order to get it set up, you have to have the laptop or local computer. This could be your home workstation. We say you have to have at least, it's good to have 100 gigabytes of disk space on this computer. You can do with less. OS X installation takes about 60 gigabytes. And if you become selective about which application you want to install, for example, for this workshop, if you want just a couple applications, you might just have a couple gigabytes available on that machine. You have to have the admin privileges on that machine, on this computer, and this is pretty much just in order to create the programs directory, which is required for the application installation. And finally, and I'm not sure how many of you would have it right now, you would have to have this SBGrid account. And principal people who run computations on SBGrid Sharp server in past, within the last year, would have this account already active. If you don't have it, you can just email accounts@sbgrid.org. And also, after this session, Michelle Ottaviano will be at the reception until 2, at the registration desk until 2 o'clock. You can go to her, and she will help you to put this account in place. So you have to have this account working, and for that you will have your login name and your password. And you can test it. If you're not sure if you have it, the best way to make sure that this account is working, you can SSH to shell.sbgrid.org with your username. And if that's the process, if you're basically logging in for the first time, it will warn you if you have your keys in place, if this machine is recognized, this will be, you just hit enter and log in. If you need to change password, if you haven't logged in within the last year, you would do it, and then your account will become active. So we have this account in place. The second thing you have to do is to download this SBGrid sync script, and we've made it really easy for you to grab it. You can just go to this website. It's sync.sbgrid.org. Download sync SBGrid sync script. You download it to your local home directory. You chmod it in order to be able to execute it. You need to change your energy settings, saver settings on the computer if you're going to install everything, because the initial installation will probably run over 4, 5, 6 hours, so you don't want your computer to go to sleep. And then with all those things in place, you can go and finally run the script. And the script, if it's downloaded to your home directory, it's still the SBGrid sync -I for the initial installation. And the script will do a number of things, but it's very simple. It will just, again, ask you for your SBGrid credentials, the login name. It will ask you where to install the application. This will go to the programs directory, and that's where all the SBGrid applications usually go. Then it will create SSH keys, and these keys will allow you in the future to log into the server without putting the login and password information. So this will simplify the update process. You put your SBGrid password. You're then going to go and select a subset of applications to install on the computer. And there are two options here. Option one is basically you're selecting nothing is selected for initial installation. So if you just want to install, let's say, HKL 2000 and MOSFilm, everything will be commented out. You go and uncomment those two applications. So that will make the installation very quick. Option two, everything is selected for installation, and you can change it out. So that's just basically running the script. It will ask you those different questions. You select option 1 or 2, and you will be presented with a text editor window. And if the applications are commented out, like the one us here, this isn't going to be installed. Everything else on this list will be included in the installation. So you just play with this window, select what you want to have installed. Once you're satisfied, you do Apple S, Apple Q to save it and quit this window and start the application process. So then you're getting the rsync prompt, and basically applications are being installed onto your computer. And again, if you're doing everything, this will take overnight. If it's a couple application, you give it a couple minutes for the installation. So that's the second step. The third step, so one of the advantages of SBGrid, we provide you with this fairly elaborate shell script, which is written by us, and which configures every single application with proper environment. So effectively, those of you who have .cshrc file in the home directory and have been tweaking with configuration, you don't have to do it. All you have to do is just source this one file, programs/sbgrid shrc, and this is for the bash environment. If you have a T-shell environment, you will be sourcing sbgrid.cshrc. So you need to know which shell you have, and it's easy to tell. In most cases, you're going to have a bash shell because that's the default right now for the newest releases of the operating system. If you have bash, you'll have to do those modifications. If you have T-shell, you just put this line in your .cshrc file. And this will permanently set you up to the SBGrid environment. You can comment it out later, but in principle, that's all you need. You can also do the temporary setup by sourcing those files manually. All right, so with that in place, you can just clean up, and this will be removing your local SBGrid sync, because we'll provide you with the new version on this in the distribution, and change your energy settings back to your preferred timeout, whatever you have. So that's the initial installation. And in the future, if you want to update it, it's very simple. You just go to the command line and you type SBGrid sync -u for update, and you don't have to do anything else. No passwords, no logins, nothing else. This will update your installation, and you can decide when you want to do it, because we don't want to cron it. It's your laptop, so we don't want you to start downloading your applications when you're finishing your presentation or something else which will interfere with your work. So you do it, and another option you have at this point is you can go and edit the inclusion file. So the file with the list of applications that you've created in the initial installation is actually saved in this .sbgrid-sync.list file. You can go back to this file and you can check your inclusion exclusions. Everything is listed here, so just remove the hash mark for things that you want to have included, and then run the update again. This will modify and get the applications installed. So that's pretty much entire maintenance of this application on your laptop. I wanted to go through those steps because it's new, and I know to some people that are not used to using the command line, that might be a bit of the barrier to get it installed. But it's really simple, and we have our experts from SBGrid sitting later tonight, and at the table you can go to them if you need additional help, and you can use this method to install the applications on your computer for the workshop. Once it's installed, using it is very, very simple. As I mentioned, you have this environment which you're going to see once you open a new shell, and this will tell you what is the latest update that was pulled from your computer. And if you have problems with installations, you can email bugs@sbgrid.org. Or submit them to our website. And starting the application is as easy as in case of CCP4, typing CCP4i. Again, zero configuration, you just typed it, and you should get the newest version of application if you recently run the update. So under the hood, you can go and look at things that, if you want to, you can actually all the applications are installed in, as mentioned, /programs directory. If you go to this directory, you will see subdirectories which are specific to different operating systems. So, for example, for Mac, you will have i386 Mac directory, which will have all the Macintosh applications, which are then inside this directory listed alphabetically. And inside those directories, you will have different versions of the application. If it's a local installation, that you will have many. If it's a laptop application, you will just have the recent version of a particular application set up on your computer. So you can go and you can look in the data files, and if something isn't working, you need to quickly modify it, you can potentially copy it to your home directory and work with the application from there. Don't go and modify anything within the programs directory, because it will get overwritten next time you update the applications. All right, so now if you run the full update, you will have many data processing applications installed on your computer. And really, in structural biology for data processing, there are 4 major applications which are used by majority of the community. And we're lucky and privileged enough to have developers from all of those packages here on site, and you recognize them from pictures here, and all of them were on the panel today. So the Star Trek HKL 2000, MOSFEM Scala, and XDS. The Star Trek installation up until now has been limited by the license, but I was just told by Jim that the program is going to be open sourced, and we will have it in September included for everybody in the consortium. HKL, MOSFEM, and Scala, and XDS are already included. Sorry, changing the wrong computer. In terms of the setup for HKL 2000, we give you, and you can just see from the number of versions for those programs how often we update them, and this is again driven by the community. The data processing applications are ones of the most commonly used by any structural biologist. For HKL 2000 is installed in many versions. You need to get your own license, so you can get this license separately, and I take it most of the people know how to do it. You do it on a regular basis. You have to contact HKL Research to get it and put it in your home directory or the user local lib directory. To start it up, you just type HKL 2000. For MOSFEM, you type, in most cases, people who use MOSFEM will use it probably through iMOSFEM interface. Again, we support many versions of iMOS and startup is easy for XDS. We have the latest version, which was released in January, and to start XDS, you just type XDS. Many of those applications, and there's some typo here. I have the newer version, but Jason didn't manage to put it in time. So then, in addition to those 4 major applications, there is a lot of additional applications which are effectively wrappers, and most of them are wrappers or additional graphical user interfaces for either XDS or ScalePack. And for example, for Muslim Scala package, we have iMoslim interface. ELSE is also using iMoslim to kind of automate the process, and is also used for other aspects of structure refinement. And ZIA2 has been recently released, and this could be used as the expert system for both on top of the Muslim Scala or XDS. And in terms of XDS, there's actually even a bigger number of applications. As you notice, many of them have been written by Kai. XDOT, XDS GUI. We also have this other application, XDSI. AutoProg by Gerard Brigon from Global Phasing. ZIA2 again as well. So there's a lot of those secondary applications that you can use, which try to make it easier for you to use the application, but still use the XDS under the hood. X-ray view was mentioned today in, I think, an opening lecture. It's also installed in SBGrid collection. To start it up, you can just type X-ray view. And we also include some applications from developers, from research groups. For example, we have this application rMerge that was developed in Roderick McKinnon lab. And there is not really much reference for that aside from this, I think, Cell paper that was published in 2011. So if you want to use it, it's there, but you would have to go to this paper to really try to figure out how to use it and what exactly it can help you with. So final slide I have, because we're about 20 minutes behind the time right now. It's about the data management. And just one thing I wanted to mention, and I think most people are aware, that one of the biggest challenges of data processing, aside of the statistics that we were aware by listening to our panel discussion, is actually dealing with volumes of data. And at Harvard Medical School, we've set up the system that basically we have a central depository. When we bring all the frames from synchrotron, we keep them there so the data is not duplicated and people know how to find it. And this has been in place right now for close to 10 years, I guess. We've also developed with Ian Stokes-Rees, who was in my group a number of years ago, a prototype system with an ECAT, which is based on this Globus technology. It's kind of a moving forward, new way to organize the data. It's in a way fairly sophisticated rsync Dropbox mechanism when you have your own credentials and you can store the data through this mechanism and you can fetch them on demand whenever you want to get them. So this has been developed as a pilot system with an ECAT, and we didn't really move forward to the production stage, but that's something that is on the discussion table. And the community is still lacking, and as you know, PDB currently still doesn't take raw experimental data. And I think we've calculated for the entire PDB data bank, 100,000 structures, if they had the experimental data, raw experimental data deposited, it would fit on 3 or 4 hard drives. So, it's been presented as a big problem of the community, but if you think about it, it really isn't, and electron microscopy and our colleagues in structural biology are taking problems like this on a daily basis. So I think, unmerged data is certainly the way to go, but from our perspective, we argue that the value of this raw images that you collected is actually in many cases something we as a community should try to address and tackle in the future. So
say that the time lag between collecting data and publishing the structure or depositing it as a PDB may be a critical factor in saving the images, because it may be that people don't have the data properly archived at home over the period of a couple years before they deposit the structure.
Right, but if the particular data set that you have if you're publishing a structure and you don't know what your data set is, I think you're in trouble.
Right,
I don't think you should publish if you cannot back it up with the experimental data, right? So, but the system we developed with Globus actually accounted for that. So we have this stage process when you basically everything you collect for your project, you archive in the Globus archives, and then when you go into publication, you go and delete what is not needed. So you don't keep accumulating, but for the duration. And this might be obviously in the cases when it takes years to publish the structure. We've seen it here when people leave, etc. There is turnover. It might happen, but in those situations, actually, it will be more useful, even more useful, because we often have PIs that come to us and they say, "We've collected data in 1998. Can we get it back? Because I want to work on it again." And we might not have it anymore. So with that, I wanted to acknowledge members of the SBGrid team and Michelle Ottaviano. She was mentioned a number of times today. And really, I used to organize those meetings a number of years ago. I knew what was happening with her on board. I basically just showed up today, and it's been a different type of experience. She's been spectacular. Ben Eisenbraun, who's been our main curator for a number of years and really is leading the project, and as I mentioned, he developed this script that I presented today. Jason Key, who's also very instrumental. Meg, Justin, Paul, who are around as well. That's our community, and if you're using SBGrid, just please cite our paper. I think members of the community have been good about citing public individual applications. The numbers for them are growing and are doing very well. We now have this SBGrid paper, and I think for our project, it will be worthwhile if you guys take an effort to mark it off as well when you publish. And I think that's all I have.